Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Then, in the previous session, we discussed about AM techniques, that is under part 1. Completely, we discussed about AM, amplitude modulation. Under that, we discussed about DSB-SC, double sideband suppressed carrier, and single sideband suppressed carrier, and power calculations and generation methods, everything. That is AM modulation technique, that is the part 1. In the case of right now, we are entering into the another continuous modulation technique, nothing but angle modulation. So, the name is angle modulation, nothing but the continuous modulation technique or analog modulation techniques can be categorized into two. One is amplitude modulation and the second one is angle modulation. So, in the case of angle modulation, today's class we discuss what is angle modulation, what are the different types in the angle modulation, and a comparison between angle modulation techniques. Then observe here, angle modulation. Before discussing about the angle modulation, first once again I am referring the definition of the modulation and the AM modulation. After that we are discussing about the difference with the angle modulation. Then clearly the modulation is nothing but, if you take the amplitude modulation, the amplitude of the carrier signal is varied according to instantaneous values of the message signal. Very, very important. Here, the amplitude of the carrier signal is varied according to instantaneous or amplitude levels of the message signal. That means, once we are observing the waveform, if you take this is a message signal, the amplitude of the carrier signal is varied according to amplitude levels of the message signal is called as amplitude modulation. Here the amplitude is varying. At this point one amplitude, at this point one more amplitude, and at this point one more amplitude. This is called as a AM. But once you take the angle modulation, what is that? Angle modulation is a process of varying angle of the carrier. Varying angle of the carrier. Observe here, when it reaches to the 0th position, the carrier angle should be changing and frequency is changing. That is called as a angle changing means. Here, the amplitude is not changing. The amplitude is constant. The amplitude is constant. But what it is changing means the angle is changing. The angle means the frequency is changing, automatically angle is changes. The phase is changing, automatically the angle is changes. That's why it is called as a angle modulation. Here, that's why angle modulation is a process of varying the angle of the carrier in accordance with the instantaneous values of the modulating signal. Modulating signal. Observe here, angle modulation is a name given to forms of modulation that are based on altering the angle or phase of the sinusoidal carrier. Altering the angle or phase of the sinusoidal carrier. That means the angle can be varied by varying frequency or phase. The angle can be varied by varying frequency or phase. That's why using angle modulation, there is no change in the amplitude of the carrier. Using angle modulation, there is no change. That means, observe here, once you should take, for example, this is the message signal. The method should be like this. The carrier angle should be simply like this, constant only. But when it reaches to the 0th of the modulating signal position, the frequency should be shifting or angle of the phase should be shifting. That is called as a angle modulation. The carrier amplitude is not varying with respect to message signal. Not varying to message signal. Therefore, there are two forms. What are those two methods or two modulation under? One is frequency modulation and the second one is phase modulation. One is frequency modulation and the second one is phase modulation. What is frequency modulation? As the same definition of the amplitude modulation. What is the definition? The amplitude of the carrier signal is varied according to amplitude levels of the modulating signal. Same as here, the process of varying frequency of the carrier in accordance with the instantaneous values of the modulating signal. The frequency is varying. The frequency is varying. Now observe here, I am taking this is the input signal, nothing but a modulating signal, and this is the carrier signal. Then observe the result at a negative peak. Observe here, the gap should be increase and decrease. At this point to this point, nothing but a positive peak, the frequency should be more. At the negative peak, the frequency is less. How you know the frequency is less? With respect to time period. Time is inversely proportional to frequency. That means mathematically can be represented. This is called as a frequency modulation. The frequency is shifted from positive peak to negative peak to positive peak to negative peak, and negative peak to positive peak. High frequencies means lower time gap between the cycles. Lower means higher gap between the cycles, the time gap. Therefore, mathematically observe here, C of t is equal to AC cos omega ct plus phi. Once we are observing the C of t value in the case of AM, AC cos 2 pi fct only. But once you observe in the case of angle modulation, the carrier signal representation should be AC cos omega ct plus theta or phi, whatever. Where omega c you know, 2 pi fc angular frequency. The phi is nothing but varying with respect to frequency and with respect to phase. Then mathematically, previously remember AC cos omega ct plus theta or phi. Then the frequency modulation is that form of angle modulation in which the instantaneous frequency Fi of t is varied linearly with the message signal. Once observe the waveform. Once when the positive peak, the carrier is also varying linearly. In the negative peak, the carrier frequency also varying linearly. That's why it should represented the instantaneous frequency Fi of t is equal to Fc plus Kf into M of t, because the frequency carrier signal with respect to message signal it is varying. How it is varying means Fi of t is equal to Fc plus Kf M of t, where Fi of t represents the frequency of the unmodulated carrier and the constant term Kf represents the frequency sensitivity. Frequency sensitivity, and it should be Hz for volts. Then you can take this value, the frequency modulated signal S of t, thus described in the time domain. Described in the time domain. What is the meaning here? Described in the time domain means if you take theta I of t is equal to 2 pi, because you can take the complete cycle 2 pi integral 0 to t, we can take the time period 0 to t, Fi of t into dt. That means this should be varying with the message signal. When it reaches to the 0th position, the angle should be changing, that is also varying with linearly. Therefore, theta I of t is equal to 2 pi into integral 0 to t Fi of t into dt. Then you can substitute this value into this equation AC cos omega ct plus theta. Then S of t is equal to AC cos 2 pi fct plus 2 pi Kf. Kf is the constant one. Then 0 to t m of t into dt. This is the frequency modulation standard equation. S of t is equal to AC cos 2 pi fct plus 2 pi kf integral 0 to t m of t into dt. Here AC is nothing but amplitude of the carrier signal, FC is nothing but frequency of the carrier signal, and kf is nothing but frequency sensitivity, and m of t is nothing but message signal information. Why you are taking 0 to t integral means once observe the waveform, it should be varying, for example from this point to this point and from this point to this point. The frequency is varying this peak to this peak. How much is varying means you can represent integral 0 to t. That's why I am taking instantaneously varying. That's why S of t is equal to AC cos 2 pi fct plus 2 pi kf integral 0 to t m of t into dt. This is the standard form of frequency modulation wave equation. Then go for the phase modulation. What is the phase modulation? Observe here. The same definition, the phase of the carrier. In the case of frequency modulation, the frequency of the carrier signal. Phase modulation is another type of angle modulation in which phase of the carrier wave is changed according to the amplitude of the message signal. According to the amplitude of the message signal. What is that amplitude? At this position the maximum amplitude. At this position it is 0th amplitude. Automatically when it reaches to the 0 to, again it can start from 0 to maximum or 0 to negative or 0 to positive. Then the phase angle is shifted. That's why the phase of the carrier wave is changed according to the amplitude of the message signal. According to amplitude of the message signal. What is that? If you take the message signal, this is the information and this is the carrier. And observe here, when it can follows, then automatically the phase angle should be reversible. That should be represent mathematically. That should be represented mathematically. Here I am taking the carrier representation because you know it is varying with respect to angle. That's why here the phi or theta I am taking. Therefore, Vc sin omega ct plus phi is with respect to message signal. The angle is varying, the phase angle is varying with respect to message signal. That's why phi m sin omega mt. Then that should be equal to Vc sin omega ct plus mp sin omega mt. What is the meaning here? It is also constant one. Therefore, this is the modulation index where mp is nothing but kp into vm. Same as previously we observe kf into m of t or kf into mp, like this kp into vm, where kp is nothing but phase selectivity and kf is frequency selectivity. This is the mathematical representation of the phase modulation, and the representation of the wave should be like this. Therefore, how mathematically theta I of t or the angle should be varying, phase angle should be varying with respect to message signal means, observe here, the phase modulation is that form of angle modulation in which the angle theta I of t is varied linearly with the message signal. That's why kp into m of t, why we are writing means it is varying linearly, therefore it is a constant one. Kp is nothing but phase sensitivity, and the phase modulated signal S of t is represented AC cos 2 pi fct plus kp into m of t. AC cos 2 pi fct plus kp into m of t. This is nothing but standard equation of the phase modulation. Then, what is the relationship between phase modulation and frequency modulation? Phase modulation and the frequency modulation. So, here I am taking the modulating signal m of t is given to the integrator, then the output should be integral m of t, and here I am giving to the m of t integration input to the phase modulator, and one more input is AC cos 2 pi fct, AC cos 2 pi fct. Then the output should be FM wave. What is that? Once observe the waveform of the FM, AC cos 2 pi FCT plus 2 pi KF integral 0 to t m of t into dt. That means when you are getting the FM signal as an output, definitely you can give to the integrated signal to the phase modulator. Integrated signal nothing but integral 0 to t m of t is given to the phase modulator, then the output should be equal to FM wave. Then the same, how we can generate the PM wave with the help of FM means simply here I am taking the m of t as the input and it should be given to the differentiator nothing but dm of t by dt. Then it should be given to the frequency modulator, then the output should be PM wave. Then the output should, what is the PM wave? Then AC cos 2 pi FCT plus KP into m of t. Then here the differentiation will come. That's why only modulating signal m of t is given to the differentiator, then dm of t by dt, and it is given input to the frequency modulator, and one more input is AC cos 2 pi FCT. The output should be PM wave. Please remember, when you generating an FM wave, you need an integrator followed with phase modulator. Generating of PM wave, you need differentiator followed with frequency modulator. That is the relationship between phase modulation and frequency modulation. Then you can compare what is the difference between frequency modulation versus phase modulation. What is that? Frequency deviation is proportional to modulating signal. Okay, frequency deviation is del f is proportional to modulating signal, and here phase deviation is proportional to, okay, phase deviation or del theta is proportional to modulating signal. Then noise immunity is superior to PM. Noise immunity is better than AM but not FM. But comparing these two techniques, FM having high noise immunity comparing with PM. And signal to noise ratio is better than phase modulation. Signal to noise ratio is not as good as in FM. FM is widely used for commercial broadcast applications. Right now we are using the FM radio stations. Just observe the channel frequencies, intermediate frequency ranges. If you take any type of FM radio channels, it should be lies between 88 MHz to 108 MHz only. Channel allocation, that is called as. That means basically on that FM radio applications we are using frequency modulation technique. For phase modulation technique we are using, especially in the case of mobile communication systems. What is that? You know, GPSK, phase shift keying methods, those all are useful in the case of mobile communication systems. Therefore, PM is nothing but phase modulation is primarily for some mobile radio services. And the last one, modulation index is proportional to modulating signal as well as modulating frequency FM. And here same as modulation index is proportional to modulating signal m of t. These are small differences between frequency modulation and phase modulation. Out of these two definitions, we observe the comparison. One point clearly, FM is used for radio applications and PM is used for mobile communications point of view. Then, what do I discuss today? One is angle modulation. In the angle modulation, we discuss the frequency modulation and phase modulation and the mathematical models of the frequency modulation as well as phase modulation with the help of waveforms and comparison between FM and PM. And the next coming session we discuss about a single tone frequency modulation process. Thank you very much.